Ladies and gentlemen, let me first introduce Christoph Hansen, Head of Technical Development of Sauber. Thank you.
So, hello everyone. So I will start with my presentation, and in the very first words I will give you a short overview about our organization, and you will see that the Sauber Group is divided into 3 companies. First of all, and the most common one to all of you, is the Alfa Romeo Racing Team. This is basically the company who is operating the race team, and they're developing and racing the race car. So this is basically the company which you see on Sunday during the race. Then we have another entity, which is the Sauber Aerodynamics. This is the company who operates the wind tunnel and is doing the aero development for the Sauber team. This company is also in charge for all aero projects for external companies. Then for today, the most important one is the Sauber Engineering. This is basically the company where all the additive manufacturing is based. We see ourselves as well not only as a 3D printing company, we are by far more. We see ourselves as well as access point to external customers, to all technologies we use to build up the Formula One car. But for today, we focus on the additive manufacturing. So what do we have installed? So on the plastic side, we have 7 large frame SLA machines with standard resins, ceramic filled resins, and on the SLS side, we have 6 big frame SLS machines. The unique thing on the SLS side is that we have there on the machines our own developed PA12 carbon reinforced. We call it high-pack, and we use this for end-use parts on the race car as well as for the wind tunnel and for customers as well. By the way, you see we partnered up here with 3D Systems. We have this on both technologies, and this allows us really to be really close to the technology. As well, we service our machines on our own. This keeps the availability of the machines pretty high. Then on the metal side, we are pretty young. We started 2 years ago. We have right now 3 big machines installed. In December, we will get the 4th one. We will also invest in the near future, beginning of next year, with extended heat treatment, like a hipping machine. And we will then finally extend our machine park as well with a 5-axis CNC machine in order to be really equipped to finalize and finish all parts in all conditions.
Too short at the time.
So what do we do with this machine park? So first of all, on the left-hand side, you see on top, these are end-use parts for our race car. These are parts which we need for the production of our race car. And then little bit more on the right-hand side, you see this is the wind tunnel application. Basically, this is how we develop our aerodynamics of the car. And then, as mentioned before, we have a huge third-party business. Here, for example, you see Patrick Lange. He was racing last year the Ironman with a handlebar which was topology optimized and tailor-made to him by us. We printed it then, and last year he won the Ironman with a new world record. Let's start and have a look. What do we really do on the race car? You see here various parts which are printed by us and produced by us. So on the right-hand side top, you see this is the roll hoop. These aluminium parts or high-strength aluminium parts protects the driver in case of a flip over, and this part has to withstand a push-off test with 12 tons. While the part itself is about 1 kilo. So you can imagine the engineering behind this part is pretty high. Then on the left-hand side, you see the tailpipe. This is an exhaust pipe. This is there a symbolic part because we print a lot of parts, metallic parts, for the engine environment as well as for the cooler environment. And these are all end-use parts. And then on the lower side, you see tooling. This is rigs, jigs, fixtures, tooling for carbon parts. So we cover here on the race car nearly all applications which are possible with 3D printing. And then on the, sorry, missed a bit the line. Yeah, now I want to go have a closer look on one application, specifically on one part, and these are chassis inserts. Chassis inserts are basically metallic bits. They are bonded into the monocoque, and they definitely see fatigue loads. These are end-use parts, and these are definitely parts you do not want to get that the part break during the race or during the season. If these parts fail, you have to rehomologate your chassis, you have to relaminate it, so it's a real pain if you have to replace these parts. And in the beginning, of course, we did this part by conventional manufacturing, and you can imagine in terms of lightweight, the limitations were quite high. So therefore, we decided to change the design and the production method to additive manufacturing. And in the very first beginning, as mentioned, we changed the design completely. So we were able to apply now all the lightweight we wanted. So we made the part hollow. We had very thin wall thicknesses. We had undercuts. So this was really, really perfectly then designed for additive manufacturing. Then once this was done, we simulated the production. And you see here the simulation with the stresses. So this showed us a bit where we have to place the support structure, where we have to reinvestigate a little bit the design. Once this was then all finalized, we started with setting up the production. And you see already here, a big part of this production is always ensuring the quality. This is why you see on the build plate here these tensile bars. So we always have to produce tensile bars, density cubes, when we do structural parts, which are ending up on the race car. Then once we have the parts produced, we do validation. So obviously we scan the parts if there is a dimensional check. We do a CT scan to see if we have somewhere unwanted porosity. And once we have passed all these steps, we have then the final part ready to bond into the chassis. By the way, this part is also in the display over there. You can have a look and see how the part really looks like in real life. So let's have now a bit of a closer look on the application in the wind tunnel. So as mentioned before, our aero development takes place on a 60% wind tunnel model. This tool has basically absolutely nothing to do with a real race car. This is a measurement tool for the aerodynamicists which are working in a wind tunnel. So as you see here, the numbers are quite impressive. So we produce around about 25,000 options per year. This is 50,000 parts. We have a production ongoing 724, and the wind tunnel itself operates 624. You see, this is really, really mass production. And the tricky thing on this topic is, you know, if you do parts for, let's say, for serial production by using additive manufacturing, you set up your process, you can learn, you validate the process, and then you're ready for production. We have only one shoot to do the part. So we get the files. In the afternoon, we put it on the machine, and we have to make sure that the part is in the corresponding quality in the next 3 days then in the workshop to assemble the model. This is a really, really high challenge, and to be honest, especially on the metal side, we have been, or let's say the learning curve was quite steep. It was really, really hard work to make this happen. Yeah, and now I wanted to show you a bit something different. So next to our race car, we also have a huge third-party business. And this example is pretty cool because the customer came to us with a 2D inkjet print head. And he had already various parts printed in plastic, but obviously the performance of the parts were not that good. The lifetime was pretty limited. So we decided to change the manufacturing method from plastic to metal. So in order to make this happen, in the first step, we really reduced the mass of the part, because whenever you reduce the volume, you reduce directly the cost. So this was really the first step we did, that we removed all material which was not really necessary. Then we integrated functions such as the radiator heater blade. So these blades you see over there on the cutting area, they surround a tube, and in this tube is a heater. By the way, this part is there to condition the ink for this printer. That's really crucial for industrial 2D printing. And Afterwards, then we added further functions which allowed us to simplify the post-processing, and we optimized the support structure because, as you know, we are located in Switzerland, so labor work needs to be reduced to the absolute minimum, otherwise we're not competitive on the market. So once we have this done then, we compared it, and we saw we had 5 additional functions integrated. The weight was reduced by more than 50%, the performance was increased by 20%, and the price was decreased by nearly 50%. So you see, this is a really impressive example. And to sum this up and give you a bit of an overview of what we're doing for these customers, so we started in Q1 of this year with 6 parts. Each part we produced 6,000 per year. We are now in the phase where we produce per part 10,000 per year, and from next year on we will then ramp up to 13,500 parts. And I think we can all agree if we say this is for additive manufacturing, this is really outstanding, and this is really serial production. And this was really, really hard work to achieve it. And if you have questions on this, then please let me know, and we can talk about it. Thank you very much.